In today's video, we'll talk about how do earthquakes occur. Earthquakes actually happen when the tectonic plates move rapidly across the fault. In this figure, you can see that the tectonic plates and in between them is the fault, which is actually a boundary between the two plates. Before the tectonic plates and earthquake, you should have an idea about the structure of the earth. Earth is actually composed of many layers. Layers can be classified according to the chemical properties and according to the physical properties. Chemically, there are three layers. Crust, which is the uppermost layer, outermost layer, mantle, which is the middle one, and the core, which is the innermost layer. And according to the physical properties, there is lithosphere, which is outermost layer, and then there is asthenosphere, mesosphere, outer core, and inner core. We are concerned with the lithosphere and asthenosphere. So let's see the structure of the lithosphere. Crust is of two types, continental crust and oceanic crust. So lithosphere is actually composed of the continental crust, oceanic crust, and the upper solid part of the mantle. These three layers combine and form the lithosphere. Tectonic plates are actually present in the continental crust and in the oceanic crust. Next, which is the asthenosphere. Asthenosphere is composed of the partially molten rocks, which is also called magma. The partially molten state of asthenosphere is actually the property because of which the tectonic plates move. Like in the easy words, you can say that the plates of the lithosphere actually float over the asthenosphere. Now we will be talking about the types of the tectonic plates. There are three types: convergent, divergent, and subduction or transform. These types are according to the type of movement of the plates. Like how do the plates move? Like in this figure you can see the convergent plates, middle one. Convergent plates are those which move towards each other. And then the divergent plates are those which move away from each other, and subduction or transform plates are those which neither move towards or away from each other, but the one plate dives beneath the other plate. Now the next question is, how do the tectonic plates move? The following mechanisms: convection current, ridge push, slab pull, and slab suction. These mechanisms are responsible for the movement of the tectonic plates. What are the convection currents? Convection currents are the movement of the liquids and the gases due to the difference in the density. How do density affect the movement of the liquids and the gases? Actually, the particles which are warm and lighter move upwards, and which are cold and denser remains behind or sinks down. Examples include warm air rises up than cold air, and similar convection currents are seen in the mantle or asthenosphere of the earth. How do these convection currents actually develop in the earth's mantle? As you can see in this figure, the brown box is the asthenosphere, and as I have already told you that asthenosphere contain the rocks in the partially molten state. Why do the rocks are in the partially molten state? Because they absorb heat from the core. The rocks which are in the molten state are warm and lighter, so they move upward towards the earth's crust. The upward arrow is showing the upward movement of the molten rocks. Near the earth's crust, they cool down and become denser, so sinks down. The downward arrow is showing the downward movement of the rocks, which have become denser and cold. So this upward and downward movement of the molten rocks in the asthenosphere is actually providing the force through which the tectonic plates move in the lithosphere. To make this idea more clear, there is another figure which is showing the same mechanism, that how do the currents develop in the mantle or the asthenosphere of the earth. The central arrow is actually showing the magma rising upward, and the arrows on the side showing the magma which has cooled down and become denser is sinking back. There is another figure showing the same process. There is inner core in the yellow color, then the outer core in the red, and then the mantle in which the convection currents are being created, which is actually the movement of the partially molten rocks. How do the rocks move upward and then come back? This movement is creating the convection current, and this movement is responsible for the movement of the tectonic plates which are present in the upper layer, which lie above the asthenosphere, which is the lithosphere actually. So we're done with convection currents. Now the next mechanism is ridge push. As we all know that there are partially molten rocks in the asthenosphere, which is also called magma. Being warm and lighter, magma move upward towards the earth crust. Now being away from the core, the magma cools down and becomes denser and sinks down. So this sinking down is actually providing the force for the movement of the tectonic plates. Gravity is also playing a role in pulling the plates down. This phenomena of ridge push occurs where the divergent plates are present, because ridge push is a kind of force that causes the plates to move away, and only the divergent plates are those plates which can move away from each other. So we can make this idea more clear through the figure. As you can see in the blue, these are the tectonic plates, and in between them is the mid-oceanic ridge. In the green, magma is rising upward, and in the dotted lines, plates are moving away, and the gravity is also playing role in pulling them down. The next process which is involved in the movement of the tectonic plates is slab pull. In this process, tectonic plates move downward towards the asthenosphere because of their own weight. Because the parts of the plates which have become cold and denser are being pulled downward due to the gravity. Gravity is actually the force which is playing role in this type of movement. In the figure you can see in the blue there are the tectonic plates. In between them is the mid-oceanic ridge. And in the green you can see that plates are being pulled down, because the cold and denser parts of the plates are actually responsible for this type of movement, because they're being pulled down under the action of the gravity. So the next is slab suction, which is also similar to the slab pull, because the plate is being pulled downward due to the gravity, but rather than just diving down, it is also rolling back. As you can see in the figure, that plate is being pulled down and are also rolling back. This rolling back is actually creating the suction current, and this suction current is responsible for the above lying plate to move downward, or the above lying plates can move towards each other. What is the suction current? Suction current is actually the movement of the magma towards the side the plate is rolling. Now in this figure you can see the ridge push and slab pull, both mechanisms simultaneously. The ridge push, as you can see, the red arrows causing the plates move away from each other, and then the slab pull. The plate is being pulled down due to the gravity. In the next figure, the slab pull and the slab suction and the ridge push, all the three mechanisms are being shown. Ridge push, as you all know, that causing the plates move away from each other. Slab pull, the plate is diving down beneath the other plate, and the slab suction, which is causing the upper lying plates move towards each other. Thank you so much.